All right. Hello, everyone. My name is Michael, Lochemem, and yeah, I'm ready to start my session, Functional Programming in PHP, right? Okay, so let's kick it. Okay, great. So I'll start with an introduction. I am Lochemem Michael. I am a PHP enthusiast from Kampala, Uganda. So hello from Kampala, Uganda. I'd love to be in Japan right now, but I can't because of COVID. But I'm relishing this opportunity to be here at this conference. So I'm a functional programming aficionado, which means I love functional programming. I write PHP, JavaScript, and some C++. I recently graduated college, currently looking for work. I maintain PHP userland packages. I maintain some PHP code as well as language extensions. I recently authored a book about functional programming, but we'll get to that later. I love hoops. Actually going to hoop after this. Movies, video games, and a bunch of stuff people my age are typically associated with. So you can catch me on GitHub, Medium, and Twitter. The links to my slides are currently available on SpeakerDeck, so you can actually be able to find my socials. But this is pretty much who I am, right? Okay, so functional programming. What is it? It's a declarative programming paradigm, which means that a lot of focus in functional programming is on specifying what you intend to do. That doesn't necessarily mean that you don't focus on, on the semantics, the core semantics of what you're trying to achieve, but it's declarative in the sense that you're always writing abstractions. Functions are abstractions, right? Functional programming mandates that you write pure functions. So it basically requires you to write functions that don't have any side effects, that don't suffer from any side causes, right? So that's very important. And we'll get to a lot more of that later in the presentation. It saliently features the use of expressions. So that means that functional programming conditions you to write expressions that evaluate to a certain result. 2 + 2 = 4. Foo concat bar is foo bar. Those kinds of things, right? And we'll get to that. And also composition, because in functional programming, you build large programs from small ones that are basically these function composites, right? So you put them together, you compose, you chain, create programs. It's functional programming, right? Okay, now before I continue, I want to make this clear. This is not functional programming versus object-oriented programming debate. No. If anything, there's some fallacies that I believe I'm going to dispel, but dispel them in such a way that I'll be providing some information that to some people might look new. So this is not a debate. This is not an FP versus OOP debate. Right. Okay, so what are the benefits of functional programming? Everything I just described. Declarative programming paradigm, one that focuses on writing expressions and composing functions. What are the benefits of doing that, right? So a lot of programs are complex. I mean, because, and I'm not talking, functions, I'm not talking about programs that just add numbers and, multiply numbers. Yes, sure, those might have their own, complexities, but I'm talking about programs that have real world applicability, programs that are meant to be viable, right? And they're usually these metastable, composites of different ideas and whatnot. Now, the complexity that I'm talking about is related to programming artifacts having histories, right? So, whenever you have to declare an instance of something that evolves over time or that changes over time, right, you're effectively using an artifact that has a history, right? Now, functions are inherently impure. Functions are inherently pure, right? And don't have any histories in functional programming. So you're not necessarily tracking these histories, these artifacts. And that's a good thing. That's a good thing because the complexity that comes with, keeping track of all of that, mentally keeping track of all that, and I'll explain what this is in relation to the cognitive burden of writing code is not really doing that, then you're able to enjoy the fullness of the paradigm, right? And also, FE techniques, functional programming techniques, they truncate the cognitive load of developing software. Writing code is an activity that requires the use of working memory, really. So transient storage, and there's a lot of transient storage, and there's a lot of and you have these placeholders in your in working memory, right? These placeholders for information in working memory. Now, functional programming allows you to reduce the strain on those placeholders that you have in memory, right? Because short-term memory is, by definition, a finite resource. It's a valuable finite resource, which means it has a limit, right? And by parameterizing things, it means that you don't necessarily have to remember the full succinctness of those things, right? So if I have a function that adds two numbers, I'll demonstrate this as have a function that adds two numbers. I don't necessarily need to remember what those two numbers are or what the histories of those two numbers are. It's just, hey, I have a function that adds, right? And so you can think of it that way. So functional programming is a technique that allows you to basically truncate the cognitive load that comes with writing software, right? Because there's about 4 to 7 fixed quanta in working memory models, these placeholders that I spoke of, right? And the fewer of these that you're able to fill up, the more working memory you have, right? So again, this is a great way to just to manage the cognitive load that comes with writing computer programs. All this in PHP, yes, it might seem like a lot, but it is possible. I know many times people bring up functional programming is they talk about the purely functional languages. Haskell, Elm, OCaml. While functional programming is at the center, at the heart of those languages, it doesn't mean that the paradigm is limited to those languages. If anything, the paradigm is in the zeitgeist right now. And I'm currently writing an article that you're going to see, an article that if you subscribe to the PHP Architect magazine, about the paradigm and about the history of the paradigm, about the lambda calculus and all those fancy things. But basically, PHP can support functional programming. You don't have to limit it to Elms, Haskells, the Elms and Haskells of the world. No. It's much bigger than that, right? So you have expressions. Expressions are basically the lingua franca of functional programming. What do I mean? Is expressions are a universal construct when you're talking about functional programming, right? Like I said, expressions are basically statements that evaluate to a value, right? 2 + 2 is 4, right? Foo.bar in PHP is foo concat bar, which is foo bar, which gives you foo bar, right? When you're unpacking arrays, right? And this is new PHP 7.4 and up, is you're effectively creating, a much bigger list with a dimensionality of 1, but essentially that is an expression that allows you to create said list, right? Object instantiation, that's another expression. So these things are really, are commonplace really in programming. So expressions are very, very, very important. What else? What is the other enabler of functional programming in PHP? Because like I said, PHP is an enabler of functional programming. PHP is functional programming affable. And a lot of languages are, really, a lot of them. So first-class functions. What are first-class functions? What is first-class function citizenry? First-class function citizenry is basically an idea that, the idea that, you can use functions as malleable coding constructs, right? You can use functions as data. You can use functions in your data structures. You can use functions simply as they are, as functions, when you invoke them. So first-class functions, when I talk about first-class functions, I talk about the malleability of functions in code, right? So you have a simple function that multiplies multiple operands, 2 and 2, 2 and 3, 4, and any, a litany of combinations, right? And you can pass that as an argument to a function, right? Creating a higher order function, right? Or you could return a function, right? also effectively creating a higher order function, right? You could use it in a data structure like an array here. And all calls to the set function will create the same result, right? So again, this just shows you the malleability of functions. And when you have this, when you have first-class functions, then when your language has first-class functions, it means it can support functional programming. So that's basically it. And that's amazing. That's absolutely amazing. Is do not forget everything you know about programming, right? So functional programming might present itself as a somewhat different paradigm, but it doesn't mean that you should forget everything you know about programming. If you listen to the presentation that's up until this point, you'll notice that the artifacts that I've just explained, right, are really commonplace in programming, in all of programming. So you've probably written, you've probably used functions as callback. You probably use anonymous functions for their inherent callback value, right? Probably done that. You write expressions every day. Yes, I'm looking at you, all of you. You write expressions every day. So why not proceed to learn, familiarize yourself with functional programming, right? It doesn't mean you should forget everything you know, right? Because everything you know is valid. Now there's functions everywhere in functional programming. It's in the name, right? And functions everywhere in PHP, right? So you have your user-defined functions, function that adds 2 numbers. That's self-explanatory. You have anonymous functions, right? These are the same thing. Again, these are great for inline value, right? So if you're writing routines that require callbacks, these are great for that purpose. Anonymous functions are great for that purpose. You have class methods, right? You can't negate these because these are still valid artifacts in programming, and I'll touch on this a bit later. But yes, you can't negate class methods. These are still vital, and you can get the same result by using the methods inside of them, calling methods inside of them, effectively calling the functions inside of them. But the catch here is you have to keep the functions pure. There can be no side effects, there can be no side causes. So your function should be basically should have safeguards for side causes and should not induce any side effects in your program. That's really what functional programming is about. That's really the gist of it. So let's look at this example right here, right? So we have a global variable, right? And then we increment that global variable inside of the function, right? Inside of this function, this add to counter function. And so when we call it with an argument of 5, it prints 5, right? It adds 5 to that value. But at the same time, rather not at the same time, like later, if later in our program we add 3 to the accumulator, then we effectively get 8. It's actually supposed to be 8. My bad. This is on me. This is it's a bad rookie mistake. But you're effectively supposed to get 8. But why? Why is this a problem? Is you've altered something in the global state. You've altered something outside of the function, outside of the scope of the function. Now, purity goes hand in hand with immutability in functions. Now, this is a violation of those principles because, like I said, you're incrementing something outside of the function with that function. So the side cause is the mutable global variable, right? Using that, and then the side effect is the mutation. So how would you improve this? Is you could use a closure that allows you to access global scope, right? And then every increment will create a different value and will not affect the accumulator, right? That's one safe way of doing it. Again, you want to keep all your changes localized to functions. That's the other thing about functional programming. You want to keep all of your changes localized to functions, right? How about parameterizing the things, right? Just parameterize stuff. Parameterize the hell out of everything, right? So you could parameterize the accumulator, right? And effectively create something akin to what I showed you, the add function that basically adds 2 numbers. You could do that, right? Again, 5 will give you 5 and 30 will give you 30, basically, if you set the accumulator to 0, but you can change that value as well. And every change will be, again, localized, siloed to that function, right? So that makes sense, right? Hope it does. The other thing that should be said about pure functions is that every input really should yield the same output, right? And that's, again, another guiding principle, another mantra of functional programming. For every input, you should get the same output, right? So what does this do? What does this lead us to? Lead us to referential transparency, which is a barometer, basically a means of testing, the purity of our functions, right? A means of assessing the quality of our functions. Again, what is the quality we're assessing? That the functions are pure. Don't create any side effects. Don't suffer from any side causes, right? Don't really have ways of mitigating side causes, right? So referential transparency is a simple principle. Really, your function calls should be substitutable with their outputs, right? So if I take you back to the multiply example, right? The product of 2 and 2 is 4. Wherever I can substitute 4, or whenever I can substitute 4 with a call to the multiply function with the arguments 2 and 2, then I can safely conclude that my function is referentially transparent and thus pure, right? So this is a great way of doing that, is referential transparency. If I can substitute my output, right, the result of my expression, because again, that's the thing about expressions, is they always evaluate to a value, is they always really, value to something, is if I can substitute that, my outputs with a function call with a specified set of inputs, then my function is pure, right? Great. So what about classes? Right? Now, OOP has a forgotten history. Now, this is what I was talking about when I said that this is not an FP versus OOP debate, right? So what we know about classes are they're composite data types, right? Encapsulation is a great way to handle and represent state data inside of classes. You have property visibility, you have inheritance is relationships, you have those kind of guiding principles, right? That effectively show you how to compose, basically write programs in that style, right? What you may not know, however, is that all of this is based on Alan Kay's biological analogy. Alan Kay is basically the person to coin the phrase object-oriented. But his intellection on the matter, his thought process on the matter was a bit different. He actually modeled it. He actually modeled the paradigm after his grand idea for computing. Basically, what he envisioned modern computing becoming. You have these cells. It's a biological analogy. So you have these cells that are communicating with each other, right? So you have these cells that have immutable state communicating with each other via message passing API, right? So he effectively modeled the paradigm after functional programming. So what should this condition you to think is, again, like I said, you don't forget everything you know about programming, because all of this on the left is still absolutely valid, right? Absolutely valid. It's just now you should start to think of your classes as more than just composite data types. Hey, I have a bunch of attributes. I have, a bunch of methods. I'm cool. Let's try to maintain the immutability inside of these classes, these objects, and let's ensure that we write pure functions inside of them. We create operations, pure operations inside of them. Basically, use them as algebras, right, in our code. So that's pretty much it. That's really it. So this is not a debate. So again, about impurity in classes, right? Impurity is endemic to a lot of setters, right? Which means that if you write setters like this, chances are you're creating these illegal mutations, at least from a functional programming sense, right? You're creating these illegal mutations. Now, each setter call effectively increases temporal coupling. What temporal coupling is it is effectively a situation where you have multiple ancestor calls, right? So you have multiple ancestor calls, right? in an attempt to create, new states that you can then proceed to modify, right? Now, that might be a lot. The summary here is you basically want to silo all your changes, all the changes you make to the state inside of an object to one instance. Again, so if you have an employee named Mike, right? And you have an employee named Chad, you basically want, all the changes that you want to make to the object that has the data for Mike. You basically want to silo all those operations to that object, right? All the Mike operations you silo to Mike to the Mike object, and all the Chad operations want to silo to the Chad to the Chad object, right? That's essentially what FP conditions you to do when you're handling objects, right? So because the cardinal rule of purity still applies, is you could either remove the setter altogether, right? So that way I have, again, the Mike object as the Mike object and the Chad object as the Chad object, right? You could do that. Or I could make the setter a pure function. How do I do that? By creating, writing the setter such that it creates a new copy of the employee. And you'll see this a lot with value objects. I don't know if anybody here is familiar with the money pattern. I think there's a library like that, is the money pattern. It basically allows you to do this, right? Only value objects are their own type of animal, but the idea is the same, really. Is you effectively want to create a new copy of of an object if you intend to create a new set of operations for that object, if that makes sense. I hope it does. But that's really it. That's the gist of it, right? So in summary, pure functions, right? Everything we know thus far about pure functions is they do not create any side effects. They yield the same output given the same input and are referentially transparent. And like I said, this applies for all manner of functions available to PHP. So really all manner of functions available to any language. Again, functional programming is not just not just a paradigm that is limited to those languages that are purely functional, right? Inherently functional, but also, but really just a more, in a broader sense, a much bigger paradigm, like a meta paradigm. So now it's time to compose the functions, right? Because like I said, as atomic units, right, functions are potent. But if you want to create programs with any real values, you have to compose it, right? And this is, you can get this from math, really. The lambda calculus is really an abstraction of mathematical principles and of a lot of programming ones, which is, again, the ancestor functional syntax. If I'll use the vampire analogy, if this is the lambda calculus is the Dracula to all this stuff, right? So f of x is x plus 1. That's a function that adds 1 to x, and g of x is 2x. You compose f o g, you get a meta function, right? That performs both actions on one input, right? So compose the functions. Now it's important to remember that whenever you're chaining, you're composing. So whenever you're effectively nesting functions, or just straight up composing them, or straight up just chaining them, right? Basically passing one input through multiple functions is you're composing, right? And this is from Eric Elliott. Eric Elliott is the author of Composing Software. He turned his blog series into a book, and I highly recommend that you read that. Yes, it's a lot of JavaScript, but a lot of that information is valid for PHP developers as well. There's a universality of a lot of these principles, a lot of these functional programming principles. So you'll likely enjoy this book. So traditionally, right, traditional composition, right, you invoke functions as function arguments, and again, you pass one input through multiple outputs, but you effectively increase, you effectively like nest them, right? Nest function calls inside of each other, right? This can get cumbersome to deal with, especially if you have long chains, like these long, function chains. This is still absolutely valid. And this is something that you get from functional programming. So whenever you're doing this, you are in many ways using a functional programming technique, right? You're doing a lot of these things inadvertently, right? So it can get cumbersome to deal with long chains when you're writing like this. So how do you make this better? Is you could use a helper library. There's a bunch of them. What these helper libraries do is they contain what these helper libraries have rather is primitives, basically these constructs, functional programming constructs, these functions, and algebras, which are really these. You could think of algebras as these structures that have some rules defined on them, right? That approximate their versions in other purely functional languages, but for PHP in the sense, again, helper library. So these basically allow you to go about writing functional code, basically ease the process of writing functional code in PHP. And in particular, we'll use this for the rest of the presentation, a library that I built. It's called Bingo Functional. Yeah, I know the self-promoting. I'm sorry. It's just this is essentially a one-stop shop for a bunch of functional programming primitives and algebras that can allow you to compose functions in your code, right? There's a REPL, so that allows you to play around with this stuff. Read, evaluate, print, loop, akin to the one that is built into the PHP engine. So if you want to experiment with all this stuff, you can do that. But this is the one that I'm using. Any of these are absolutely valid. You don't have to use mine, but for the rest of the presentation, I'm using this. Again, apologies for self-promotion. Now, point-free composition. Again, because we covered traditional composition where you nest functions, right? And you pass one argument to all of those, right? Now, I remember when I spoke of abstraction, if you can think back to when I spoke about functional programming being a declarative programming paradigm, where you essentially you're specifying actions, right? Is actions, again, that are ultimately built atop, a certain set of, semantics, right? Is, the addition is going to happen somewhere, if you're going to add, or creating an uppercase version of a string is going to happen somewhere. But essentially what we're doing when we're writing functions and when we're chaining them is you want to specify what these things do. You basically want to call them in such a way that you're specifying what they do, and you're feeding them into this long pipeline. You're effectively creating pipelines, programming pipelines, processing pipelines rather. So this has the same effect as an earlier snippet. And effectively allows you to print the message Sophia's a nice city. Sofia in Bulgaria. So this is point-free. The point-free style is essentially a really nice way of composing functions. It's more compact. And caveat here is it works on functions that have an arity of 1, basically that have an argument count of 1, right? Okay, so you're thinking, okay, there's a lot of functions that take more than 1 argument, right? And I'll show you there's ways to go about creating, basically truncating the size, the arity of functions without compromising their fidelity, their integrity, right? Another thing I want you to be mindful of is that you can use consts for functions, and this is especially nice for projects that contain these namespaces, the projects that contain namespaces, right? Because when you want to use the point-free style, right? If you notice, PHP basically allows you to use strings for function names, right? And that's, to me, a cool feature. So if if you have your functions, namespaced under, a specific name, right? It's easy to proceed with the point free style if you use const for functions. If you basically bind these function names, if you basically assign these function names to constants that don't change, right? These are invariants. So that way, if you look at the snippet in the slide, is you have an add prefix and you have a truncate function, right? And so when you call those somewhere else in your code, right? Namespace specific functions is I can use the point free style with the compose helper function, right, to create my pipeline, and I can specify the names of these constructs, make my code look a lot more compact, right? So it's really nice to use const. You don't have to do this if you're okay with writing these long function names, then hey, go for it. But this is really a nice way to do things. Right. So some more FP sauce to add to your program, right? More techniques that you can use in your program. In your programs, really. Partial application, currying, map, filter, fold, pattern matching, and persistent data structures, right? These are all really nice things to use. It's all really nice artifacts that come from set of ideas that are built off of ideas, right? That I'll be explaining shortly. And you might have used some of these techniques before, not necessarily in the same way that they're depicted in the slides, in these snippets, but you've probably used something that approximates to some of these ideas before. So again, it's not entirely new. The paradigm isn't entirely new, right? Right, so we'll start with currying, right? If you want to decompose your function into a series of subfunctions, right, you can create curried functions. What this allows you to do is defer your function calls, right? So if you want to only specify a certain number of parameters in one step and follow that up in another because of, say, the rules of computation in your program, or because of the data flows in your program, and the data flow, the ordering, the chronology of the data flows in your program. It can be a litany of reasons. This is a great way of deferring function calls. Now with currying, you're not altering, you're not changing you're not changing the functions internally, right? You're effectively deferring the binding, right? So the invocation, you're effectively deferring the invocation. Now, the thing about currying is that every subfunction, right, has an arity of 1. So basically, every subfunction that you create from currying, every curried function, right, creates subfunctions that take 1 argument. Let's look at this, like a simple quadratic, right? A, B, and C, 2 roots, right? Usually a positive and negative one, but depending on the values of A, B, and C, you can create solutions to a litany of quadratic equations. Now, if I curry this function, right, I can pass the arguments 1, 4, and 4. Extract my 2 roots at the end, at the last with the last function invocation, right? Is every time you do this, with every function call, you're basically creating a new function until you pass the last argument. That's really how you think about this. And like I said, why this is inherently good is if you're using the point-free style, is you can pass as many arguments to the function up until you create a function that has just the 1 argument, just the sole argument, and then create that pipeline in there. So you could find creative ways to use currying in your program, right? Combine that with the point-free style. And then you have partial application, which is similar, right? Also useful for deferred function calls, but this time every subfunction you create, every subfunction that is created, as a result of partial application, has variable arity. So you can pass any number of functions to the subsequent functions created from a partial application operation, right? So I hope that's not confusing, but essentially with curring, where you pass a single argument, where you pass a single argument to every subfunction. With this, you can pass multiple arguments, right? And then you have map, filter, and fold, which basically allow you to transform lists, right? Arrays, objects. So map basically allows you to apply a transformation to every value in a list. Mind you, all three operations happen in a single iteration, which is a good thing, right? So with map, you transform every single entity in a list with per the semantics of a function. With filter, you effectively trim a list based on a Boolean predicate specified somewhere in some function, right? And with fold, you effectively flatten a list into a single value, again, based on the semantics of a function, right? Right. And the fold operation in particular is very, very versatile. Like you can derive filter and map operations from fold. It's very versatile. And these are, again, operations that I recommend that you use in your code, right? You can achieve these natively with array map, array filter, and I think array reduce. These are all native functions to PHP. Only the modifications here allow you to use those with objects as well. So the modifications in the library allow you to use those operations on objects. Pattern matching, right? Pattern matching is a technique that is present in many functional programming languages. It's commonplace in many functional programming languages, right? And it is useful for selectively processing data with discernibly different patterns, right? So when you think about pattern matching, think about the switch statement or something like the switch statement, or situations that might require you to use these conditionals, if else if, all these those kinds of control structures, right? Think about pattern matching. It allows you gives you more control over processing discernible patterns. What do I mean? Is patterns are either really simple, right? Numbers 1, 2, 3, 4, 5, 6, positive infinity, right? Strings, foobar, etc. There's a litany of those. Those are really simple patterns, right? Those, and then you have these more complex tree-like patterns, right? A URL, for instance, right? HTTPS this, that, foo.com, or HTTPS youtube.com or zoom.com, or those might require different processing. Those might come with their own set of processing constraints, right? And you can't treat them the same way as you would just a single number. Pattern matching affords you this ability to succinctly describe what you intend to happen to these artifacts, to these patterns, but with functions, right? And these are especially good for flow control, right? Now, in pure functional languages, they're purely functional languages. They're baked into the respective engines, compilers, and whatnot. Here, with a lot of extra plumbing, you can get functions that perform pattern matching but are composable as a function, right? So you can create a simple router like the one in the snippet here. What this does is it effectively behaves the same way your fast route would behave, or your routing component in your framework might behave. Is it looks for the discernible patterns in the URI path, right? And then performs apt computations, right? For instance, we have books that are indexed by publisher, right? Leanpub packed. Again, more self-promoting. Man, Right. I should get flagged for this. Like, so yeah, leanpub and packed, right? And you have an endpoint that is books/publisher, right? Again, these are, this is data that is indexed by publisher, right? So if I pass the constraints are such that the router basically returns for every valid publisher, for every publisher that is available in our tiny data store, right? In a tiny data store, it returns the book that matches the publisher. So effectively, we're matching against the index, right? So books leanpub will give you functional programming in PHP, right? And then books Manning, because we don't have any Manning entries in our data store, won't return anything. We'll give you a 404, right? Book not found. And then any other type of route will basically give you a bad request because that doesn't exist. Again, you can change the logic based on what's apt for your system, what's apt for your program. But essentially, that's the gist of it, right? So flow control based on evaluating discernible patterns, right? That's pattern matching. And then you have immutable lists, which are persistent data structures. Persistent data structures are those that effectively create a new copy of themselves with every transformation. So with every modification, which is usually a pure one, you create a new version of the list, if that makes sense, right? Because if you can think back to when I spoke about how class and objects are treated in functional programming, is the purity comes from creating new objects and siloing every operation to each object, right? So I want to treat Mike differently. I want to treat Chad differently. If I have employee, if I have an employee object, right? Now, immutable lists are simply list data structures that output new copies with on every transformation, right? And a lot of these transformations happen in a single iteration, a bit of a recurring theme. So when you look at this, when you look at the snippet in the slide, is created an immutable list, the numbers from 1 to 100,000, right? And I want to filter out all the even numbers, right? Get all the odd numbers, and then I want to square those, right? So that's another transformation. So again, the rules of forward function chaining still apply here. Is I'm effectively specifying these operations. I want to filter, I want to map, I want to do this, this is consistent with the themes of abstraction, the themes of chaining, composition. So this is really a nice tool to add to your arsenal, a nice technique to use if you're building your own lists. And if I'm not wrong, these are more performant than regular arrays, so you might want to consider using these. And there's a bunch of libraries that do this as well. So now we'll move on to real world I/O, which is real world input output, and it is messy out there. It's bad. And you thought the dating world was bad, but this is real world I/O is messy, right? And this is the stuff that we do almost every day. Is we interact with real world input output, because everything I've described up until this point is effectively just simple operations, multiplication, addition, concatenation, whatnot. Is you're doing stuff in the real world. You're trying to connect to this database. You're trying to make a call to this API, right? Is those kinds of things. And many of those operations are inherently impure, right? And many of those operations require you to use exceptions, which are also inherently impure, right? And we'll see why. And so I/O just gets really complicated. Okay. So what about this impure I/O? What could you describe as impure input-output? File system interactions. Read from file, write to file, write to standard output read from standard input, right? That type of thing. Opening windows, right? Database interactions, database connections, those kinds of things are all impure input-output, right? So I said something about exceptions and why they're inherently impure is because they don't really return a value. They don't evaluate to a value. They strain the runtime and are not good for function chains because they break the rules of referential transparency. You can't, when an exception is thrown, you don't really get a value out of it, right? So, again, look at that instance when the exception is thrown is you don't get a value out of it. So how do you create a chain on top of that, right? See? So how do you cope with this, right? You use functors and monads. And man, I'll let you know on something is when I was creating this talk, I wanted to, offer just, bite-sized, just easily digestible explanations of these structures. I know functors and monads, you might hear these things, endofunctors and whatnot. No, I'm not going to talk about them like that. They're actually a lot easier to use in normal, rather than what a lot of people might tell you. Favor composition for function chaining again, and then using persistent data structures. So functors and monads are algebras. Again, these data structures that have a set of operations defined on them, right? So that's essentially what they are. That's essentially what an algebra is. This is really programming with effects, right? Programming with effects. So what is a functor? Simply, what is a functor? It's just something you can map over, right? Typically a type class, right? So you can implement it as such. It's a type of category, really a type of algebra, right? That supports forward function chaining. So how does this happen is you map onto it. So I have a value 2, map onto it an operation that increments it by 2, I get 4, right? Map onto it another function that computes the square of that, I get 16, right? So that's really what functors allow you to do, right? What about monads? Monads build, top functors, and they have amazing ad hoc value, right? But they are themselves algebras and are bound by specific rules that essentially allow you to do all manner of stuff, function application, again, forward function chaining. So these are really important, but are, for the most part, monads are, they have a certain specificity to them, right? And we'll see this. Real world monads, the ones you can use in your programs. Either and maybe, which are great alternatives to using exceptions, IO for handling your input-output, the state monad, the reader monad, the writer monad, right? So let's start with the maybe monad, right? So you have these two subtypes inside of them, right? Just and nothing, right? Just is where you'd put the value you want to, mutate, right? The value you want to change. And then nothing is really a unit type. Unit type is null. So nothing is really just nothing, right? So in situations where you might have, again, why you use exceptions is because you want to handle anomalous situations, abnormal situations, right? So where you'd have something abnormal is, hey, just return nothing, right? And then where I get a value, hey, return that value, but return a transformed version of that value. That's essentially what this is conditioning you to do, what this type of monad conditions you to do, right? So it's a bit like the union types. If you've looked at PHP internals, the C stuff is you have unions evaluating to only one at runtime. So again, there's a lot of evaluation that happens in the background that can allow you to effectively jettison exceptions from your code altogether, right? Then you have the either monad, which is similar, only where you'd have nothing, right? You have an error value, or you have an object that allows you that in which you'd subsume some sort of error value, and it's a discretionary one. So if you want it to be a full message, divide by 0 exception, or you can put that in there. But the principle is the same. Is hey, if you're going to give me something that works, something that fits my logic, okay, return a transformed version of that thing. If not, give me that error, but just don't strain the runtime. give me a value, give me something that is referentially transparent, right? That's the gist of it. That's the gist of the iterator monad. And what this effectively allows you to do is write two-track functions. Write a function that handles success, write a function that handles failure, in accordance with the railway pattern, which is something developed by Scott Wallash, and you can follow that. It's a really nice pattern for writing code. So just like in the previous snippet, basically only add 10 to values that are greater than 20. Otherwise, return 0 in the left block, in the left object. And that's pretty much it, right? So no need to throw an exception, less than 20, exception, error, no. Use the iterator monad, right? IO monad, right? Great for IO related stuff. Read from file, put string. This snippet here basically allows you to read from a file, right? And then print that to standard output, pipe that into pipe that into the console and display that in the console, right? So the IO monad basically allows you to do that kind of stuff. It's great for IO if you have a network request, if you have you have a database request, you have all these kinds of things, right? You should consider using the IO monad. The state monad, if you have an internal state that you want to return along with the transformation of that state. So if I have something and I want to return the earliest version of that thing and a transformed version of that thing together, then I use the state monad, right? So basically what this will do is I have an on value false and default value 0, right? So I will put inside of that monad a function that increments the default value, the base value, right? And I'll change the value of on, right? If that value exceeds a certain number, if it's greater than 0, right? So what this will effectively do is return my original state on false value 0, but the transformed version of that as well, right? So the final transformed version of that. So it's great if you want to maintain that. And then similar to that is the reader monad. If you've used dependency injection in object-oriented programming, right? Then you can achieve something similar with the reader monad. What it allows you to do is pass what you'd call an environment, but is really a configuration of some sort. It could be a simple variable, could be something composite like a list, could be an object, is essentially to pass that into an environment where you have all these functions that that effectively transform the value inside of that object, right? And then return the result, right? So it's it's useful for sharing data among these functions. So if you have again some configuration like something from an env, and you have a bunch of functions that read from that env, you can chain them up all together, right? Chain them inside of the reader monad, right? And then pass your env variables into that, and then get your result, right? So you have here a function that prints hello name, a greeting, really, right? And then you have an extension to that greeting, which is, hey, if the name that I pass, right, is world, right? Then really don't print that. Don't print the how are you stuff, right? So just get me the text if it's hello, if it's a world that you're giving me, right? The world name world. But if it's anything else, then print hello, how are you? That's essentially what it does in that snippet. And then the writer monad, which is good for logging data. So kind of like the state monad. No, not like state monad. Is with this, if you've done some event sourcing or something similar, is if you want to keep track of changes, every mutation that you make, every transformation rather, with the forward function chaining, like if you want to keep track of that, is you specify that inside of the reader monad. So effectively what the writer monad, what effectively writer monad returns is your final value, your final transformed value, and your and effectively your logs, really, the logs for everything that happened throughout the life of that monad, of the use of that monad, right? So yeah, really great tools to use. Now, how do you know that you're doing this functional programming thing right? How do you know you're doing it right? Is your functions are pure, your functions are for the most part referentially transparent, You're composing more, and there's a conciseness that comes from, utilizing the fullness of the abstraction, specifying what you want your program to do, right? Creating these pipelines, creating these chains, right? So before I conclude I want to remark that the future looks bright for functional programming in PHP. Why? Because of the language. The language has inherent support for the paradigm, as I explained at the very beginning, right? And also there's new language features which make it easier to write functions, right? There's new RFCs, there's new libraries, there's more explanatory material, like my talk, like the articles that I've written. There's more explanatory material that will allow you to learn more elucidatory material. And like I said, all around language consistency, which is language support for the paradigm, right? And before I conclude I wrote a book about functional programming in PHP. So if you feel like you want to learn some more, this opus here, this book contains a lot of information about, different patterns you have functors and monads, you have, error handling with, maybe in either types, you have just a bunch of things. Functions, how to do threading, and how to basically approach I/O in functional programming. Just a bunch of stuff is available in this opus, and I recommend that you get it on LeanPub. Right, that concludes my talk. Thank you so much for having me. Thank you, conference staffers, for everything that you've done, accepting my proposal, sending the shirt that I'm wearing right now. I want to thank everybody who's watched this for staying attentive, and just try to compose stuff, I guess. That's it. Thank you.